Hi, everyone. I'm looking into a screen here talking to you. So, how to curl better? First, I just wanted then to let you know that I am Daniel Stenberg, of course. I founded curl back in 1998. I'm still the lead developer, and I do curl development full-time every day these days. I'm employed by Wolf SSL. We sell commercial curl support for those who want it. I've been doing this for a long time, and I figured this would be a fun time for me to just share some tricks and tips about how to do curl. And I'm sure that a lot of you know what curl is and what it isn't and what to do, but I'm going to tell you anyway to sort of get everyone on board, and I'm sure that there can be some tidbits for everyone. So first, a little bit of a roundup here, what curl is, what it isn't, and how it come to be the way it is for everyone, because it's different for everyone. And why is that, right? And then I'm going to run over a bunch of different options and a little bit how to and why they exist as they are, and what options to not use so much perhaps, and why. So, and then of course a little Q&A in the end. So if you have questions really about anything curl, but possibly about what I'm going to talk about, so go ahead and fill them into the question thing that Johan is running here. So, and I will get to them in the end. My plan is here to not talk for a completely long time, but maybe 30-40 minutes, and then we can have discussion on questions and answers, and then I'm going to be out of your face, and you can go on and do whatever you want. Okay, so curl then, just to get everyone on board here, is an open source project. We do a command line tool, and we do a library. We transfer data into, well, we actually do internet transfers, right? We specify the transfers as URLs. That's why the URL in the name. Curl can do a lot of things, supports 24 different transfer protocols and a busload of features. And here are some of them that are sort of just packed on one screen. We can ignore that for now, but we can just agree that curl is sort of a Swiss Army knife for internet transfers. It can do a lot of things, and I'm going to get into some of those things today and explain a little bit about concepts and everything. But first, who makes curl, and how did it end up like this, or how is it like this like now? So curl is pretty much the result of 2,200 contributors having helped out over the years. And helping out means basically anything: writing docs, reporting bugs, coming with code, stuff like that. And we're about 770 authors who've written code merged into the Git repository. About 150 of these authors write something per year, and we're about 12 people that actually do 10 commits or more per year, and we're basically me doing that every year for the 22 years now. So a lot of people involved. So it's I might be sort of the captain on the boat, but I'm certainly not alone in this venture. So curl has to some extent already sort of conquered the world. And the image here on the right is the NASDAQ building in New York with a fancy curl command line on the big screen there. So, but how come it conquered? How come we've been sort of successful within air quotes so far? But we sort of created curl at the right time, before or in the beginning of the sort of internet boost. I started my first HTTP stuff in 1996. The first curl version came in 1998, and then we sort of surfed on the internet, big internet wave. And it's been open source. Everyone can run it everywhere, and it's really, really portable, so you can run it on whatever operating system or platform you want. And of course, it is also backwards compatible. That means that it's easy for everyone to write something, depend on it, and it'll just keep on working. You can upgrade your scripts and upgrade your curl over the years, and it'll work the same way, and you can be sure of that. And it's also a very stable product. So all of this makes it very easy for everyone to rely on curl and use curl for whatever you want. So, and it also then exists in many places. We started in 98. It ships, actually, it still ships in Mac OS since 2001. It's been in the stock Windows 10 since 2018. It's in every Linux distribution since a long time. The first Linux distro added it in '99. And of course, it's available in all the other operating systems too. And if not, you can build it from source. And a lot of people also build it from source anyway, for various reasons. And it also exists in a lot of different flavors, right? So there are millions, literally millions, probably billions of build combinations you can select on and off among roughly 30 dependencies, like TLS libraries, libraries for SSH, libraries for compression, libraries for a lot of different things. So any random place you find curl, you may find that they've selected a different set of third-party dependencies that they built curl with, and then it ends up differently. And we also have very frequent releases. We do releases every second month, basically. So given time and different distributions, different third-party, and you will also see different versions of curl wherever you use curl, basically. It's very rarely the same in two places. It also supports, as I mentioned before, a lot of protocols and options. And today I'm going to stick to talk about curl, the command line tool, and not the library curl. Library libcurl is vastly used by applications and devices and everything who wants to build internet transfer powers into their tools or devices. But I'm going to talk about the command line tool curl here, the one you've seen in the prompt or running your scripts. It knows a lot of protocols, 24 transfer protocols, as I mentioned, but there are some other protocols, of course, under the hood. But today I'm going to talk about specifically one protocol. And of course, since curl supports all these different protocols, all these different features, it has a lot of command line options, 230 of them as we speak. The 231st option is being added and will be included in the next release. So we're constantly adding new options to the command line tool, a lot of them, as you can then imagine. So I'm not going to talk about all of them today. Of course, I'm going to talk about HTTP and HTTPS in this presentation. I'm going to limit my explanations to a subset of the options, to sort of some of the important ones, some of the cool ones, maybe some of the ones you didn't really know and care about before. So I wanted to show you this little graph I made the other day. This shows the number of command line options over time in the curl project. So we started out with 24 options, command line options, back in 1998, and we are now at 231 in a month. So yes, growing fast. Okay, but we're talking about HTTP and HTTPS today. So what is HTTP? HTTP is this simple protocol. You've seen it a lot of times. You know what it is. Basically, here's you, and there's the server. And what do we do with that? Right, we send a request to the server, we send a method and a path, we send headers and possibly a body. And we get that back from the server, right? Response code, we get headers and a body. That is HTTP. And it looks like this if you look at it from a more protocol dump way. Here's a request with some headers, and here's a response then with a response code at the top, the 200 there, and headers and content. That's the body. You've seen it. This is the same thing. It basically has looked like this since the mid-90s. It looked very similar before the mid-90s too, but HTTP 1.0 introduced this look basically, and that came 1996. So anyway, that's HTTP then. And curl is minimal behavior by default, I call it, or I like to call it at least. So that means that it does only what it has to do and nothing else by default. So there's a basic set of headers, and there's no fancy functionality. And so you have to, if you wanted to do something more than just the basic stuff, you add that option and you tell it to do the other things. And basically all the options that add things or ask curl to do anything, they're on and off. So if you want to add two different things, you have to do it with two different options, and you can turn them on and off individually, which means that you have a really fine-grained control exactly what curl will do and understand and not do on and off. If you just want the basic stuff, you don't tell it to do it. If you want it fancy, you ask for it. And of course, just a basic command and option thing, there are long options and short options and by name, right? So you could, for example, use -s. I will say dash for that minus sign in front of s here. I call it dash. So you can use -s instead of the longer version called --silent. And a lot of options, of course, won't have the short option because 230 options, there are not enough letters in the alphabet to actually have short options for them all. But there are a lot of short options. I think there's a single letter left for short options, and it's a quiz for you to come up with which of the letters aren't used yet. But so that's the options and how we use it. Okay, a zip coffee. Here we go. So we start out with curl, the most simple way you can do it. You just ask, you want to do an HTTP GET. That's curl, and you enter, in this case, not even a URL. This is just a host name, right? But curl will assume that this is actually a URL, so it'll transform it to a URL for you. Maybe you meant http://example.com, and it'll do that for you. And you get the response body on the screen because you didn't tell it where to go. So it got just sent to standard out. So this is more like how maybe Unix commands are typically sort of usually work, send everything to standard out. But you can then also get to see the response header. So in this case, we now write the full URL here, https://example.com, and we add the -i to get the headers included in the output. So then we get the response code, we get headers back, and we get the body. This is still a GET request over HTTP. Fancy. So yep, now you get to see the headers and you get to see the body. And of course, if you wanted to do something with the body, what if you get some fancy content here? If you would, for example, get JSON, you could pipe it into the JQ tool, JQ being a cool tool to handle JSON, and it'll show it in a fancy way, like this, right? Instead of just everything on a single line without any new lines in a blurb. If you would do this with an image or a movie or a sound clip, you would, of course, not want that on your terminal. You want to save that to a file. But you can also check the URL, for example, with a head request. Just ask the server about details of the resource. So you ask with a capital I, -I, and it'll set a head, and you won't get any body. You will only get the response headers. Just some info. You can see the size, the date, the server info, and whatever. And it's a 200, so you know the resource exists. And there's no body because head doesn't return a body. It never does. Okay, easy peasy, just the two simple little things. And again, curl only does what you ask it for. So it does everything as basic as possible until you ask for something more. So if you, for example, do like this, you query a resource that's redirected. Redirected being HTTP lingo then for it should actually ask for another resource rather than this. This has moved, or you want to go to the other place. So if you ask for head here, you get the content, you get the 302, which means a redirect, one redirect kind. There are several different kinds, but we can ignore that for now. And it says a location, which actually is then the pointer to the new place. But yeah, and there's no body. But curl won't go there. You will still just get this because you haven't asked curl to follow the redirect. You just basically investigated the sign here. You didn't follow the sign. So instead, if you wanted to actually follow the request, you would add in this case, the -L, which is then asks curl to follow the redirect. And then you would get both first the redirect code, and then it'll follow the redirect, and you will get the sort of the final destination. And it would actually follow a lot of redirects here. If this would be redirected several steps, it would follow all the steps. which could be a lot of them, and it has a loop detection, so it'll actually stop after a certain amount of redirects, so it won't do it infinitely. So this is how it works then, right? So you have to ask for everything to enable it, otherwise it won't do it. Another little fancy thing that is sometimes forgotten about with curl is that it supports what we call, all right, no body, what we call URL globbing, which is a feature that some shells provide on their own, but some don't, and curl supports it natively. So you can, for example, get a range of documents like this automatically, 1 to 9 here, all those web pages in one go, and it'll send them, in this case, all to standard out, which is probably not what you want. Or you can get everything with a 0 prefixed, 1 to 99, 0 prefixed, or you can get A to Z in an alphabetical range like this. And you can even do more fancy stuff. You can take every other step from 1 to 9. So it'll just step by 2 and step by 1 by 1. Or you can do that with letters as too. This steps 3 letters at a time. And in case you don't want this saved to sort of sent to standard out or the terminal, which you rarely want, right? So you can save them like this, and this is a fancy little thing. So you can see here the pound sign, the hashtag in the -o option here is this for the saving. So it'll actually get that parameter from the range in the URL. It'll be the first range will then be put there. So this will save files, save _1.html, save _2.html, save _3.html, and so on. And you can also do comma-separated strings like this. So it'll get this different ham, cheese, and pineapple images and save them as JPEGs like this. And of course, you can combine everything in one command line if you want to. So you can ask for both ranges of different kinds and the separated, comma-separated lists. And you could, of course, save that in different output files too. So it could end up in a real large amount of transfers if you want to. And sometimes when you do all this fancy stuff with curl, you will find yourself in a position where curl doesn't do exactly what you want, and you're wondering why doesn't it work? What should I do to fix my command line? So then you add this -v, and it'll show you a lot of details. V for verbose, of course. It's actually -- verbose if you do it in the long version. And it'll tell you about things like IP addresses, protocol details, TLS details, and then you will also see the actual request going out. You won't actually see the request body in this case, but a lot of details, and then you will get the headers back, and you will get the body as well. In this case, the command line saves the body to dev null, so you won't see it. But always remember, -v is a key to solving your issues. That helps you see what is getting sent and help you understand what's wrong and right with your command line. And when that is not enough, you don't add more Vs. I know some Unix tools or Linux tools, you can add more Vs to get more verbose, and a lot of people then add more Vs like VVV or whatever. But with curl, that doesn't change anything. You can have as many Vs as you want, but it won't change anything. You won't get more data. So what you want to do instead is I'll show you later because there's more tricks to getting more info. But I just wanted to say a few other ways to extend your HTTP request is when you want to provide custom HTTP headers in your request. Maybe you want to send a magic disco header in your request, or you want to set a special user agent in your request because, let's be honest, some servers will deny your request if it sees that it's curl. But you can say that you're discoing the night, and then you might get your response back. And you can even remove the user agent header completely by doing it like this without having any right side of the colon. It'll remove the header from the request. And you can do this little magic thing by putting a semicolon there. It'll send a blank field for this header in the request. So you can this way you can handicraft your request to look exactly the way you want, or mimic another client, browser, whatever you want to do. If you want to post basic data, like for example, you want to send an update to a web page or log in or anything. In this case, for example, I want to send my name is Daniel to this server. I just put it with -d, and it makes a simple post to that server, and you get a response and everything back. In this case, we have the -i, so we get the headers back on the terminal, and we get the content too because we didn't send the content anywhere. We can post a file, which just prefixed it with an @ sign, so @ file name, and it'll send that as a post. We can post from a standard input, so just pipe whatever, and we post with an @dash, and it'll post the standard input instead. Or we can ask curl to treat the file's binary, so don't ignore new lines or anything, and just send it exactly as is. Or we can use that and send a binary from a file as well. And we can add a header, custom header. Like in this case, if you want to send JSON, sometimes you want to tell the server that this is actually JSON coming in the post. Then you could do it like that. And then when people start doing things like this, you often want to do, for example, you also want to do post is one way to send data to a HTTP server. Put is another. Put is usually a way to sort of replace, instead of sending data to a resource, it's actually more meant to replace a resource with this content. So they're similar but slightly different in semantics. But then you do it like this anyway. You just use the uppercase T and you put a local file like this. And it'll push, and in this case we had -i again, so we get the response headers and we get the response body because we didn't save it. And if we are not happy with post and put and get and head, we can change the method we send to the server with the capitalX option. So we do that this time. So we want to send a put, but we want to change the HTTP method. So we send it as a swoosh instead, like this. Easy peasy. But here's the key here. The -x should be used sparingly and only for the cases where you really want to use something else than what curl can do by itself. So you shouldn't. It's a little bit tricky thing to use there. So I'm going to explain why. So using capitalX too much can lead to pain. So for example, here's the typical case that we see a lot of people. This is one of the most abused curl command line cases in the on the internet. You want to post something here, like post data. You send it to this site, and we add this -X here for no good reason, because this will do a post anyway without us saying so. Like that. We don't need that, right? So then we do like this. Oh, we want to follow a redirect as well. So we add this -L at the end. We want to follow the redirect that we get back from this post. But this is probably not what you want. And this is a very common mistake, because now it'll send post when following the redirect as well, which in often cases this wouldn't do otherwise. So basically avoid it. So it means that capitalX means that it'll use that in all requests, even when it follows redirects. Otherwise, the redirect code will tell curl what method to use, and -X will override that, and you will be sorry and unhappy, and it'll not work the way you want to. So only use -X if you want a different method than curl would use itself. To put shortly and just briefly, and just remember this, avoid it. Don't use -X unless you really have to, but you very rarely have to. So, okay, going further and faster into cookies. Cookies are just headers, really, and we already seen how we can add headers and in requests, but cookies are more sort of advanced headers. So they're really name value pairs we send in headers, or we get them from a server, we can send them back from a client if it matches sort of conditions like host name and path parts and everything. And again, curl doesn't know about cookies unless you ask curl to know about cookies. And then it works like this. You, for example, All right. First, I wanted to mention that you actually have separate options for reading cookies from a file and writing cookies to a file, and sort of saving cookies after a session. So you would do like this. Here's a final example. Save all the cookies from this site. So you would request a page from this site. Any cookie you get back, or cookies, a number of cookies, it'll save in the cookie jar. And then you could, for example, do another request to the same site and read back the cookies that you saved in the previous invoke, and it'll send those cookies back, exactly like a browser would, or any other HTTP web client would do. And so, you could use both of them in the same command line, and it'll work with cookies. And here's an example. I just wanted to show you roughly how such a cookie jar would look like. This is just a very basic, simple, fake cookie. It would look like this. It doesn't really matter what all the fields means, but I just wanted to show you that there's a text file with the contents, with the cookie, the contents of the cookie jar. So okay, and in a typical login case, if you wanted to, like how you log into a website with a browser, if you would do that with curl, you would typically combine a post and saving cookies. So then you would do like this. You would save cookies, for example, when you go to the login form of a special site, your own favorite site, and on that login form, maybe you want to provide your username and password, and you want to make sure that you use the cookies and you save the updated cookies. And in this case, bam, if you get logged in by that request, you can, in your third request here, actually request data on that site as a logged in user. This is sort of just the basic steps how most modern websites actually work these days. You log in with a post and you keep session as a cookie. It'll be slightly more complicated sometimes when the sites uses a lot of JavaScript and other things that ruins your day. But okay, this is the basic concept at least. And today, of course, as I mentioned or seen or everybody knows, we're using HTTPS, right, for everything these days. So you want to try to get stuff from your own site with HTTPS instead of HTTP, but then you run into problems, right? If you do it like this, if you try to get a web page from your local host, for example, you will see that you have certificate problems because your site on your local host won't have you don't have the certificate for this IP address, right? So it won't work to do like this. So then you can ask curl to ignore the certificates checks if you want to, but we don't condone that, and it doesn't work for cookies either. So if your host actually is named something, it doesn't work when you access it with the wrong name. Then you can do like this. You can provide a host header to the site. And then this actually makes it work with cookies. But it doesn't work with virtual servers because virtual servers, when you do it with TLS, you want it to have the proper server name in the already in the TLS handshake, and this doesn't. So it doesn't work for that either. So curl has another way to do it. And this is the fancy way to do. So you add the --resolve. This is basically a way to provide an IP address for a host name that you make up, or rather you provide the IP address for whatever host name you want. Like this, if you want to access example.com on your own host, because you want to have run your own copy of the example.com server on your local host, you can just tell curl that this is the IP address for example.com right now. So this makes it work with TLS and certificates, and it works with cookies, and it's virtual. It works even if you have virtual setup. So if you run more than one server on your local host, it'll work for that too. It's a pretty convenient way. You can even, there's also another option that's called connect to, which is slightly different, but achieves almost the same thing mostly. So here you can actually tell curl to connect to another host name instead of the original host name, and even change port number if you want to. So you can do a lot of tricks if you want to access a server on a temporary site, like when you develop the site, or when you want to test just one particular load balancer, perhaps out of a set of many. So you know where to go, and you don't want to use the ordinary DNS round robin or whatever it does. So, okay, you can do a lot of fancy things. So let's see other fancy things. Oh, right, let's just pause and say, don't use -k to disable certificate checks. No, avoid it. So you want to get more details out of your command line curl tool. So then I mentioned before how using more V's in the verbose option doesn't help you because it won't add more data. So instead, curl provides this option called --trace ASCII. There's also actually one called just --trace. They're similar, and they add a lot more detail. They basically send everything. They show you everything that curl sends in and out, sends out and gets in. So it'll help you identify exactly what is going on. So like in this case, you can see this is a simple post sent to this server, example.com, and then you can see like this, exactly what kind of a request looks like, what kind of data it sends, that it sends the exact send this data as a post. Down there, you see the third line from the bottom, you can see the post data getting sent out. And of course, this is a simple case, but in more complicated cases, you can verify that the post or the request looks exactly the way you wanted and intended it to be. And you can see every single byte that curl gets back to, and you can verify that it actually is, it matches whatever you think it should look like. So other ways to extract sort of information from your request or transfers when you use curl, the command line tool, is the funny writeout option. -w. So you use it like this. It's as a string with a bunch of variables for you to get data out of curl with. So you use it like this, basically writeout, and then it's a text, and you have variables in there to use. And you have fancy and fun variables. There's a whole range of them. I think there's around 30 different ones so far. You can get content type, you can get HTTP version, remote IP address, local IP address, you can get download speed, and we're introducing the JSON variable that I know a lot of people are looking forward to, which will output all of these variables as a JSON object. So soon you will get everything as a JSON object. So information is not actually data from the transfer, but it's information about the most recent transfer, like this. You would use writeoutjson like this, -w, and this %brace JSON brace, which is a way of just specifying that we want that variable output, and it sends the variable output to standard out here. So we save the actual file to with -o, we save it to file on disk, and we pass this, in this case, to JQ again, because JQ is a cool JSON tool, and it'll look like this. Maybe not color coded like this, but anyway, it'll pretty print it. That's JQ doing it. And so this is JSON coming from curl with metadata about the particular transfer from that URL right now. Nice, right? So running forward, so what if you do all of this and you think, well, I want to do a tool of this instead. Instead of running my command lines, I want to write a libcurl using tool that does the same thing. And then curl has the fun command line. One of my favorite command line options to curl is the --libcurl option. So you use it like this. You write the curl command line, whatever curl command line you can think of, really. You add all the options, and then you add this --libcurl and the source code.c. And curl will then generate that source code, and then you compile that source code and you run it, and that application will then perform the same operation as your command line did, like this. If in this example, if you would do that, just getting that example.com URL, it would generate a source code that looks roughly like this. It's a template. It does the transfer. In this case, a very simple transfer, and it doesn't add anything magic, but that's the header, that's the source code for it, and you could just build it immediately and run it, and you have your own libcurl using application. And it's a really good kickstart, because whatever you want to do, of course you don't, I mean, you want to do something slightly more advanced than this possibly, but this is a really good way to get going, get started with your libcurl using application. And of course, and here's slightly advanced, whatever you want to do, like with you a lot of use cases come from, you sit somewhere with your browser, you've done something, you want to make sure that you can redo that operation with curl after you've done it the same way the browser would do it, like log into that site or download that file or view that image. And then all browsers nowadays, Firefox, Chrome, Edge, and Safari, they all have this copy as curl option. These are 3 different screenshots. They're fairly old by now, but so it basically probably looks a little bit different these days in all of them. But all of the major browsers, they have this copy as curl option in their networking debug tool. So if you go into this debug tools section of the browser, and you can see all the different requests for a website, and you can select one of those lines, and you can go into the right-click it and select copy as curl, and then you get a command line copied to your clipboard for a command line that would use curl to get that request exactly the way the browser would do it. Basically like this, bam. Here's an example of Firefox doing a request. And as an example, actually, it gets the curl front web page, and the exact same web page from Chrome. It looks like this. They're long and a bit overly complicated, but this is because it sets the exact same header set that the browsers are using. Anyway, that's the way it works. So if you have a command line, if you have a request you want to mimic with curl from a browser, it's an easy way to get started. And of course, after you do this, you usually go through this list of options and trim it a little bit and make sure that it actually does exactly what you want to and not the way you got it copied from the beginning. So it's the first step, it's not the final step. And if that's not enough, you can do like this. You can do enter the SSL keylog file way of spying on your browser or spying on curl and making sure that everything looks the same. Especially if you, for example, want to mimic several steps of operations that your browser does, and you want to make sure that curl does the same thing, maybe, then you can snoop on them and make sure that and verify that they look and behave the same, right? So you just need these things. You need wireshark, and you need this environment variable called SSL keylog file, all in uppercase, no spaces. And you tell both, well, like this. You specify to wireshark where to load TLS secrets, and SSL keylog file tells the tools where to store the secrets. So basically, they should point to the same file. And curl and your browser can save those secrets in that file and make sure that wireshark uses it like this. You set the environment variable to path name, like perhaps like this, TLS key. I just made up a path here. You can use whatever path you want. And then you run curl. So, and that of course doesn't help you, right? But then you need to have wireshark fired up on next to that. And then in wireshark, you go into this pre-master secret log file setting, which is under the SSL protocol section. And then tell wireshark, read your secrets from here. And when you do that, you can then enable wireshark to snoop on the network traffic, and it will automatically decrypt and analyze the TLS traffic for you, even if it's completely, it's TLS. So it's no longer encrypted and hidden from wireshark, so you can actually see the protocol stuff in detail. In this case, the screenshot here is an HTTP2 transfer, a lot of HTTP2 frames, just showing off how it looks like when you analyze TLS traffic. And you can do that with curl, and you can do that with the browser. Both Firefox and Chrome support that SSL keylog style. Okay, and of course, curl supports a lot of different protocols, and we talk about HTTP here, but curl also supports a lot of different HTTP protocols. HTTP 1.0 shipped in '96, as I mentioned before. Headers looked that way. We learned how headers look like back in the 90s. And in 2015, we shipped HTTP 2, and HTTP 2 sends headers slightly differently, but we like to pretend that it doesn't in curl. So even though there are now different HTTP protocols, HTTP 3 is coming. Curl supports it in an experimental way now. Curl still pretends that all headers look and work like they did in HTTP 1.1 or 1.0. So all headers will appear as they've always done. So whatever you tell curl to use HTTP versions, if you ask it to use 1.0, 1.1, 2, or 3, the headers will, you pass to it, and the headers you will get back, they'll still look the same way. And the actual HTTP version will be sort of, you won't really have to bother about that. It'll say which HTTP version it uses, so you will know it, but the headers and everything, it'll look the same, pretty transparently. So it'll make sure that even if your servers upgrade to version 2 or version 3 and your curl scripts do as well, you still can use the headers the same way as you did your headers 20 years ago. HTTP 3 support is experimental. It works mostly. You should try it out. It's fun, but it's not the final thing. Oh, right. And if you want to do adding even more spice to this, if you think you want to do a lot of different things on the same command line, and a lot of people do, right? Because if you do it on the same command line, we can reuse a lot of caches, reuse connections and everything. Like in this example here, we can send the same post to 2 different URLs. Send user, the user is Daniel, to both these URLs. But maybe I want to send a post first and then a get from another URL. And then I could do it like this. I add the -- next option in between, which will pretty much reset the command line option parser and go back to the default. So in this particular example we're looking at here on the screen, we first send a post to the example.com domain, reset all the command line options, and then we have a get to the next one, because that's the default method. We can also sort of reverse the option and do get first and do the -- next, and then we send a post to the second URL. And of course, there's no limit to the number of URLs or -- next that you can use. So you can use that a lot if you want to or feel the need to. And then, of course, since it doesn't quit here in between, it'll reuse connections and caches and everything. It'll be much faster than doing multiple command line invokes. So, and by this, I hope that I've sort of teased your imagination a little bit about what to do with curl and how to figure out how to do it and use it better and everything. I realized that I've only sort of touched on, what, 12, 14, 18 different options, and there are many more. Many of the options are, of course, protocol specific, so they won't really matter for HTTP. But these, I hope I at least showed you some of them, and some of these things was actually new to you and interesting. So get in there, start using more curl, and avoid -X, and don't use -K either, but try out everything. And of course, all that I said here in my little presentation here today, all of this and a lot more is also documented and detailed in this little book, Everything Curl, which is my attempt to document most of the curl project options and curl command line and everything in curl, really. So that's why it's called Everything Curl. So, and it's available online in PDF and the web version. So go read that if you want to dig into all of these details even more. And of course, feel free to help out in the project. We always need and appreciate your help to get even better code, bug reports, patches, yelling, whatever you think we need in the project. So help out. Thank you. Any questions here?
Yeah, exactly. Hi, thank you very much for this talk with so many deep insights and tricks. We do actually have quite a lot of questions, so let's get to them. So the first question is by Drew Fusitny. Are there situations where it is better or easier to use wget?
Yes, there are, of course. And let me just sidestep that for 1 second and say that we don't have that much of a big of a wget curl war, really, but I like to entertain that notion. It feels fun. But of course, I would say that wget, of course, it has this recursive option, which is primarily one that curl really doesn't have. So if you want to download one resource that links to other resources like images or style sheets or whatever, and you want to get an entire website or whatever, then wget is of course your friend, and curl will make that really hard for you. So that, I would say, that's the obvious case.
Okay, great. Then the next question is, how did you decide on the name and the pronunciation of curl?
Well, it of course has a longer history. Since I started working on when I started working with HTTP client, I called it HTTP GET from the beginning, because I based it on another tool called HTTP GET. So I started off. I didn't even start it myself. So, and then it grew into URL GET when it got more support than HTTP. And then one day I started supported upload as well. And then URL GET turned out to be a bad name as well, because it wasn't only GET anymore. And then I wanted to change the name in one way to make sure that I didn't have to keep changing it all the time. And then I wanted it to be short. I wanted to have URL in the name because it worked with URL. And then, names are really hard. I came up with URL. Maybe the C could stand for client, and it could also stand for just C, as in sort of a fun pun, as in see the URL. So that's where I went with curl. And of course, pronunciation-wise, it felt like, how else would you pronounce curl? It's actually an English word, and you call it curl, curly, curl. So of course, it would be pronounced curl. That was easy.
Okay, great, thank you. Then the next one here is by Jesper. How do you test curl before releasing it, considering all options and build variants?
Oh, that's a good question. It's really hard. I would imagine. I would start a preface. So we have a huge amount of CI. We have a huge amount of test cases, and we test a lot of different build combinations and on a lot of different platforms and tools and everything. And of course, we do that to a large extent. But no, we don't test all combinations, and we don't test all possible platforms, and we don't. So no, we do as best as we can, but there are, of course, white spots that we don't test enough. And usually we try to test all the popular combinations on all the popular platforms, and hopefully that'll cover it good enough. But of course, there will always be some gaps that we miss out. I think usually we end up in a pretty good place.
Okay. Then the next one is, does curl from Windows have all these options? Isn't it just an alias to some PowerShell command?
First, curl, the project that I participate in, that I founded, we of course make curl exactly the same on all platforms. So curl on Windows, it actually will work exactly the way it does on all the other platforms. So, and we've shipped curl on Windows for, well, maybe we didn't do it the first few months, but we've done it for almost 22 years. And then when we made curl popular everywhere, suddenly one day, Microsoft, in their infinite wisdom, decided that they should create an alias in PowerShell that's called curl, that is almost completely a broken curl that doesn't work like curl, but you could make an alias. And I don't know why. It was never a good idea. I've complained to them, and somebody might know that I also sent them a pull request to remove that alias when they made the code open, but they rejected my pull request. But anyway, since they've also nowadays they ship the real curl. So since March 2018, which I mentioned in my talk here, they ship the real curl, not the alias. They ship the alias as well, but they ship the real curl as well. So it's our code shipped in Windows 10 since 2 years back. And that works the same way as curl does everywhere else, with the same caveats that they, of course, have selected a set of dependencies and build options for their particular build. So when you run curl on Windows 10, it might not work exactly the same as when you do run curl on your Linux distro or something, depending on the version and the particular build options they used when they built curl in the Microsoft HQ.
Okay, thank you. Then, if you had the opportunity to restart today, would you still have chosen C as your programming language?
Good question. It depends. If I wanted curl to become what it is today, there wouldn't be any other choice, I would say, because because of many reasons. Because curl runs on has run or is running on 72 different operating systems. It's run on 20 different CPU architectures. There's just nothing comes even close when running on these funny new computer languages. So sure, I could rewrite it in Rust if I was happy with the 3 major platforms, or maybe 5, and so on. So sure, that could have been. But if I wanted this 10 billion installations or something that we count on now, I would say that C would be mandatory to get that coverage. And we have a lot of our users using it in tiny devices on obscure operating systems and everything. So I think C has been one key factor to why curl is as widespread as it is today. So yeah, it depends on what I wanted to do. I would stick to C.
Okay. And the next one by Henrik. Does curl support globally set options like the wget-rc file for wget?
Yes, it does. I mean, the curl command line tool has a .curl-rc file that it supports for reading options at start.
Okay, great. And then Frank asks, are you a fan of the -lol option?
Hi, Frank. Yes, of course I'm a fan. So yeah, since curl has a lot of options, and also also since you can basically all the letters are used for something, you can make up fun sentences by making sure that you just so the LOL is one of those fun things. I remember one of my favorite options. I think it's a Stack Overflow option, when someone said that the -oj is a killer option, and I think that's one of my favorites. Well, for the younger ones in the audience, you might not catch that, but still. So yeah, you can make up really funny, and the same thing that, when you add more V's to -v, it doesn't add anything. If you add more capital L's, it doesn't add anything more either. So LOL is of course the same as LO, capital ones. So yes, you can make up funnier just command lines by adding more letters to it. So yes, it's a game we have.
Yeah.
I know, Frank.
Okay. Then Drew says, that libcurl is great. Thanks for the tip. And then I have a personal question. How do you approach UX of the command line tool with so many options? Does it grow organically? Do you sometimes break backwards compatibility, or how do you do that?
We don't break backwards compatibility, which is one of our problems. But that's both a blessing and a curse, right? So it's a blessing for all the users that have something running since 15 years, so they don't have to upgrade their scripts. It's a bit of a curse when we come up with or understand that maybe we did it really bad 5 years ago. There wasn't such a good idea to do it that way. Now we have a much better idea how we wanted it to be, but we can't really remove the old stuff because that's the way it's been working for a while. So therefore, the UX is not ideal. It grows organically, and it's grown in a few different ways and styles. So I think it hurts usability in one way, but it then also benefits because it has the great benefit that all the command lines that ever you worked before, they still work. So if you actually have, if I wrote a mailing list post 12 years ago explaining how something worked, it still works that way. So documentation is really easy to maintain as well, right? Because it's the same thing, and we can just add the documentation all the time, and we basically don't ever risk that we actually have to go back and find outdated documentation and make sure that we document the new way. Well, we have a little bit of that anyway, but sort of not so much, at least. So I think it's both good and bad.
Okay, great. Thanks a lot. That was all the questions. And thanks again for the great talk. I at least learned a lot. So, okay, then take over, Johan.
Yeah, thank you very much to both Daniel and all our viewers and all our sponsors.
And with that, I would like to thank our speakers, our sponsors, and all our viewers.